Hi, everybody. Well, we have Anthony here. Good to see you. And we'll wait the standard moment. Okay, well, I'm going to go ahead and get the ball rolling and get started here. Welcome back to Curiosity Corner Live. My name's Andy. Bow ties are cool. I'm here at the Great Lakes Science Center. We are now open, so you can go online and order tickets and come to the Great Lakes Science Center. So I'm broadcasting here from an area that we call the Hive. You can see there's a few things behind me. It's always weird. There we go. So we have supplies back there, and we have little radios that we use to talk to each other. And I have a lot of cool stuff that I'm going to talk about. So today's episode is all about chemical and physical changes, as you can see from the title there. And when I mention physical change and chemical change, those are two different kinds of changes that we can describe in science. Oh, Isaac is here. Hello, Isaac. So when we talk about physical change and chemical change, there are two different ways that things can change. And I'll explore the difference between the two and some examples of physical change and a few examples of chemical change. So a physical change is something that is easy to reverse, and a chemical change is not so easy to reverse. That's the basic definition. A chemical change requires a chemical reaction. A physical change doesn't. So for instance, if I take this piece of paper and I rip it, now it's two pieces of paper. It's still paper. And if we had enough microscopic glue to take every single fiber and fuse it back together, it would be a whole sheet of paper again. This is still paper, this is still paper. We just split it. That is a physical change. On the other hand, we have chemical change. Chemical change is if I, for instance, burned this piece of paper. That would be a chemical change. And actually, I'm going to use a very tiny... We have a lighter. Don't try this at home. It's fire. Don't try it at home. There we go. So, fortunately, it didn't catch on fire and burst into a huge flame because I can't afford that right now. But you can see on the edge there, hold it up to the camera, and maybe if the camera would focus on it, but the edge there you see is burned. I'm going to try burning it a little more. Come on. You can see that flame when I burn it, and it turns into ash, it glows, it lets off that smoke. That is a chemical change. We cannot unburn this paper. Some of it turned into smoke, some of it turned into that black line there, that coal, that charcoal, that carbon. It changed from paper into other chemicals. So we can't reverse it. We can't unburn something. So ripping is a physical change. Burning is a chemical change. It takes those chemicals, reacts them, and changes them. Now, I've defined what a chemical change is and what a physical change is. Let's see if we can identify them. I have a beaker of water here. If I froze this water, if I change this water from water, liquid water, into ice, do you think that is a physical change or a chemical change? If I cool this down into ice? Is that a chemical change or a physical change? Because it's changing from water into ice, but is that reversible? That's the big question. And I will grab another ingredient here for a future, very shortly, we're gonna do another little experiment here. Physical, yeah, it is actually physical. Turning water into ice, freezing anything, that is a physical change because it's going from one state of matter to another state of matter, and Isaac's correct, it's reversible. If we heated that ice back up, we would get water. Same thing if we boiled this water, it would go from liquid to gas, and then we could condense it back into a gas. I mean, back into a liquid from a gas. So that's an example of a physical change. A state of matter changing from one to another is physical. What about cooking? Is cooking a physical change or a chemical change? If you saw my episode on Monday, it was Monday, all about kitchen chemistry quirks, that may be a good hint for you. Is cooking a chemical change or a physical change? And continue getting ready for this. Okay. That's baking soda. And if you're stumped by the question if cooking is a physical change or a chemical change, you have to think about whether it's reversible. Cooking largely is chemical. There's a lot of different things going on. With cooking, if you cook an egg, you can't uncook an egg. Cooking has a lot of different reactions that are happening. Heating something up and then cooling it down would be physical, but if you take an egg and you fry it, it turns solid because all those proteins change, because it's a chemical change. So for the most part, cooking is a chemical change. Here's another tough one. I have a teaspoon of baking soda and I have my water from before. If I take this and dissolve it in the water, so I'm mixing it up. I have baking soda and I'm mixing it into the water. I'm dissolving it in the water. Is that physical or is it chemical dissolving? Getting something like sugar or salt and dissolving it in water. I can use the scoop. Now here's something really mind-blowing. I should probably not use that scoop, never mind. I'll just use the whole jug. Dissolving or dissolution, making something dissolve into something else, like if I dissolved that baking soda in the water, which I did, the baking soda or the salt or whatever you dissolve in another substance, that is actually a physical change because the baking soda is still in here. It's just combined with the water, but not in a chemical way. It's sort of trapped in there. It's still in there. This is water and baking soda, and I can kind of prove that it's still in there. I have a little bit of vinegar, and I'm going to pour that in here, and we'll see if it fizzes. Yeah, there you go. So you can see the fizzing. I dumped a little bit of vinegar into that water, and it's fizzing now. It's fizzing because of the baking soda. The water is just sort of like, the water doesn't care. So there's still baking soda in there, which proves that dissolving baking soda in water is a physical change, but reacting baking soda and vinegar, that is a chemical change because those bubbles are carbon dioxide gas, the baking soda, sodium bicarbonate, is reacting with the acetic acid in the vinegar. Those are two different substances. They combine and they make those bubbles, as well as something called sodium acetate, which we might make a video about in the future. Sodium acetate is really cool. Those bubbles are a proof that the baking soda vinegar reaction is a chemical change. And Anthony asks, can you take the baking soda out of the water? Yes. So right now we can't, because that baking soda has changed into sodium acetate and carbon dioxide, and so we would have to reverse that reaction. But if we just dissolved baking soda in water, all we would have to do is boil the water and we would have the baking soda. So the baking soda never changed. It was just trapped in the water. So there's some things that seem like they're chemical changes when they're actually physical changes. And there's some things that might look like chemical changes. There's some things that look like physical changes that are actually chemical changes. Sometimes it's not easy, and sometimes the two things happen all at once. So you could have a physical change and a chemical change at the same time. For instance, if this reaction was what we call exothermic, if it had a lot of heat, then we would have the chemical change of the two chemicals reacting, as well as the physical change of, say, water boiling or freezing or something like that. Now, that brings me to your challenge for the day. Your challenge is to look around you, maybe find some safe household substances like baking soda and vinegar, and see if you can identify chemical changes versus physical changes. Like look at something like photosynthesis in plants, and ask yourself, is that a chemical change or a physical change? That's my challenge to you. And before I go, I'm going to introduce you to somebody you may have noticed sitting here. If you're longtime viewers of Curiosity Corner Live, you know that I have this little unicorn toy that sometimes makes an appearance. Well, I have a new one. This is Candy Corn, the pony corn. We have Powdered Sugar, the pony corn, also. They're sisters. Just a little fun thing. So sometimes you might see this one in my silly videos because I'm a very silly person, and sometimes you'll see the other one just for a little bit of fun. I'll see if I can like hide her in the videos every so often. Anyway, thank you for watching today's episode of Curiosity Corner Live. Don't forget to come back tomorrow. We have another exciting installment for you. It's going to be a lot of fun. And as always, thank you for joining us, and stay curious.